EVA is a tool for the development, testing, and deployment of vaccination knowledge. We're looking at the main user interface screen for testing of EVA, and the case we're looking at is the simplest possible implementation of knowledge. There is only one vaccine in the system at this point, and that vaccine only has a single dose given at birth. But this simple case can illustrate many of the capabilities of EVA. In the blue, we can see the data, the input data for a particular case. This test case, which is ID number 1, is for a newborn infant who has received no vaccinations. The results are some in green and some in yellow. The green results come from the database of stored results. Whenever we want to keep some results for regression testing, we can keep it in the database, and then we can compare the previous results for a given test case with the current results to see if any changes in the knowledge have in fact impacted some of our previous test case and known good results. In this case, the history, which is the analysis of the past vaccinations, is empty because this individual has not received any vaccinations to date. But there is a plan for the future, and this individual is due for a BCG. They're due for dose 1, and over here we can see the optimal ranges, as well as a citation, which is the India Academy of Pediatrics, and a comment that they're on the standard BCG schedule. We can run another test case. So we go up to our EVA menu, and we select a regression test case, which is our number 2. And analyze the vaccinations. And now we're looking at a newborn infant who has had 1 BCG at 2 days old. In this case, we now have a history that there was 1 dose, the status was okay, and it was given at the recommended age. And both our current results and the data agree. There's a plan, and in the plan we note that BCG is complete. We don't need any more, so there are no dose information, and again the same citation. So how is that knowledge stored in EVA? Knowledge in EVA is of 3 basic types. One is definitions, part of a taxonomy or an ontology of information about vaccines, how they're going to be used, type families such as whether or not they're live viruses or not, or combination vaccines. For example, MMR is a combination of measles, mumps, rubella, and they can be handled together or independently, etc. EVA is capable of handling all these kinds of situations. But in this case, we have one very simple vaccine. It's BCG. We're going to use it for historical analysis, and we're going to use it for planning purposes. And that information is recorded right here in this simple table. The other types of knowledge are schedules in tabular form and rules for how to apply the schedule and for exception cases. The schedule is put in a table like this, which sits very well in the Excel environment here, and allows us to say what the minimum age is, the minimum intervals, and the recommended ranges for this particular vaccine. In this case, there's only 1 row because there's only 1 dose to the vaccine. The rules are encoded using A-Rules XL, a rule language that is integrated as a plugin into Excel. There are 2 types of rules in general for a given vaccine. One is exception kind of rules, and the other are how to apply the schedule. Here we see the exception rule, which is when is a BCG schedule complete, and that would be when the valid count of BCG is greater than or equal to 1. For this rule, we want to then note that the status is complete, make a comment about that, give the citation, and information about the dates for next dose, etc. are irrelevant, so we leave those blank, but we note that they're there if needed for other situations. Down here we have a rule which is how to apply the schedule. Again, this isn't really necessary for the simple case, but it's the type of rule that would be used for more complex schedules because it generically applies the schedule to any dose anywhere along the schedule. In this case, it's due when BCG count is less than 1, and we set the dose equal to the valid count plus 1, which will be the next dose that we're looking at. And we set another variable called the minimum date to the last dose plus the scheduled minimum interval. So this is one minimum date, which is the last dose, plus the minimum interval. We then compute the status, and that means that EVA will take the date of the vaccination and compare it against the schedule to see whether we're before the minimum age, between the minimum age and the minimum interval, the recommended range, which would be it's eligible but not due, recommended range is due, etc. So that's how EVA will compute things. The minimum date for this particular vaccine is going to be the maximum of the minimum date based on the minimum interval and the minimum date based on the minimum age. So it's going to use the minimum interval and the minimum age to determine what the actual minimum date is. The same with the recommended dates, the ranges for the recommended dates. So we have rules here and we have schedules here for how to apply them. Those are two of the types of knowledge. We saw the definitions, and those are all here in the user interface. And that provides a brief introduction to the capabilities of EVA.